Okay, all distinguished ladies and gentlemen, good afternoon. Assalamualaikum warahmatullahi wabarakatuh. First, let me introduce myself. My name is Rana Yusuf Nasir from Maskeei as the chair of the board of expert Maskeei. And in this session, I will act as the moderator. Secondly, it is my great pleasure to see you all in this virtual breakout session with the topic of net zero energy building and energy efficient household. This topic is very important since we know that our planet Earth threatened by global warming issue, which the expert already projected that the global temperatures will increase more than 2.5 degrees centigrade in the year of 2050 because at that time the greenhouse gases emission will increase double than the current level of the greenhouse gases emission if we do nothing. It's said in our flyers that the COP in Paris already decided to limit the global temperatures increase not more than 2 degrees centigrade in 2050. But however, this data need to be corrected because there's something wrong there. The latest information I received that the decision of the COP Paris saying to limit the global temperature increase not more than 2 degrees centigrade in end of the century 2100, and until now the recommendation has not been changed. But however, the IPCC recommend to the UNFCCC to limit to not more than 1.5 degrees centigrade in the year of 2100. And to achieve this target, the greenhouse gas emission should be reduced to the level of 50% of the current greenhouse gases level. On the other side, building sector contribute about 39% of the greenhouse gases emission, only produced by the energy sectors. Therefore, there is a recommendation for the building sectors to implement to net zero energy building and goes for the efficient technology and energy for the building facility and utility. All of these above issue and the problems will be presented and will be delivered by our four amazing speakers as mentioned in the flyers. Ladies and gentlemen, please allow me to give a brief in the time slot of the session. Our session will be ended at the 6 p.m. It means the total time for this session is only 90 minutes, which means for every speaker, we will give a time slot of 15 minutes for presentation and another 5 minutes for Q&A, with a total 20 minutes for one speaker. And the time slot for 15 minutes per speaker will be strictly to be followed because after our session, it will be followed by other breakout session for this evening. Therefore, as a moderator during the presentation, I will give two signals as a reminder for the speaker. The first signal will be given 5 minutes before the time runs out, and the second session will be given 2 minutes before the time runs out. If you, as a participant, has a question, please you may write the question through the Q&A panel. Do not forget to give your name, to whom your question is directed to, and the content of the question. This question from participant will be raised in the last part of this breakout session. Should the time not allow to continue, then the remaining question will be answered by email. And the session will be conducted either in English or in Bahasa. Speaker may choose language which they want to use. A simultaneous interpretation services will be available in English and in Bahasa. Zoom platform has a button to click to operate to the interpretation. So about the session, I will start by sharing the biodata of the speakers and followed by the presentation from the speaker. After the first speaker finishes the presentation, I will give the question to that particular speakers about the presentation. After the answer from the speaker, we will continue with the second speakers, the third speakers until the fourth speakers. Which since then I take a question for the participant as mentioned earlier. At the end, before we closing this breakout session, I will give a summary of all the materials that we have discussed during the session. Okay, now is the time. Let me start now with the first speaker. Ms. Maxine Jordan from International Energy Agency, IEA, with the topic of Towards Not Zero Energy Building, Developing a Roadmap for Energy Efficient in Building. And she is in Paris now. Now it's about, the time is 11 something. And please allow me right now to read her biodata. She holds a Master's of Engineering degree from University of Cambridge in Civil, Structural and Environmental Engineering. Several years working as a building services and environmental design consultant in London. At the IEA, Maxine has led the development of regional roadmap for building and construction for Asia, Africa, and Latin America. She also provides policy support and analysis for building and cooling efficiency across the agency. She also leads the energy efficiency in buildings work with the IEA Energy Efficiency in Emerging Economy Program. So let me start with the presentation. Ms. Maxine, now is the time for you to give the presentation, but please not more than 15 minutes. Now the time is yours.
Should I go ahead now?
Yes.
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 Okay.
Please share the share screen.
So you should be able to share my screen. Is that correct?
Yeah. Please try to get an access for the share screen. Have you clicked the share screen button below?
Yes, I have, and it's telling me that I'm sharing.
Okay.
And it looks like it's okay. No?
No, there's. Yes. Okay. It shows ready your presentation. So please go ahead. Yeah.
Perfect. Thank you very much. Thank you very much for your introduction and for kicking off this breakout session. Good afternoon, everybody. And yeah, thank you for having me. It's a great pleasure to be here. I wanted to kick off with a couple of figures from the IEA's recently launched NetZero roadmap, which was launched about a month ago now and is available. And this net zero roadmap shows what a possible pathway to net zero emissions by 2050 could look like for the energy sector. And from this figure, which is about the building sector, you can see that buildings' operational carbon emissions currently account for around 28% of global energy-related emissions. And if we add emissions from the manufacture of building materials and construction, this actually goes up to almost 40%. So building sector accounting for about 40% of global energy-related emissions. But if we consider for a moment operational carbon, so the carbon emissions coming from the use of energy within buildings, we can see that while activity could more than double by 2050, meaning more floor area, more access to energy services, higher living standards, still through behavior change, energy efficiency and electrification, as well as some other technologies, we could actually reduce our emissions significantly and get to a 97% reduction by 2050. So one of the key things from this slide is really that behavior and energy efficiency could account for nearly 70% of these buildings related emissions reductions through to 2050. So I'll be talking a little bit about how to actually make that happen. So in the net zero, this is another couple of figures from the net zero roadmap scenarios. And we see here that space heating is transformed radically in the net zero scenario, with homes heated by natural gas falling from about 30% of the total today to less than 0.5% in 2050. And homes that use electricity for heating rise from nearly 20% of the total today to 35% in 2030 and about 55% in 2050. But also building envelope improvements in a net zero carbon ready retrofit and in new buildings account for the majority of heating and cooling energy intensity reductions. And we can see that through deep retrofits and the construction of highly efficient new buildings, we can actually reduce the average cooling intensity by about 25% by 2030 and almost 50% by 2050. So this is showing how much heating and cooling intensity could decrease by addressing the building envelope. And now a couple more indicators to sort of show us, in order to get ourselves on such a pathway, what else would the building sector need to achieve? Because those were very high-level outcomes. So in the roadmap, we've defined a series of what we call milestones, and these can serve as indicators to assess how on track we are, but also show us the scale of the transformation that's required. So the indicators that are shown here include energy intensity improvements, which need to be front-loaded with about 6% improvement per year in the next 10 years, going down to about 4% and then 3% per year. Then we have the share of the building stock that is net zero ready, which needs to grow from less than 1% today to 20% by 2030 and almost 100% by 2050. We also have an indication of how much the stock of heat pumps and solar thermal systems and LEDs would need to grow. And for example, LEDs would need to account for 100% of lighting by 2030. Also related to energy efficiency, appliances need to get more efficient, consuming 25% less by 2030 and 40% less by 2050. And distributed PV generation also grows significantly. There's one main indicator that I'd like to go into a little bit deeper today, and this is the one that says that all new buildings would need to be zero carbon ready by 2030, so in less than 10 years. But first, I also wanted to explain what is meant by a zero carbon ready building, because this is a term that's used a lot in this roadmap, and there are also many different definitions around. And the one that we're using is this concept of zero carbon ready buildings. So first of all, the zero carbon covers, in terms of scope, it covers the carbon associated with energy use in the building, through electricity and other fuels. And it also, so that's scope 1 and 2. And then it also includes the carbon emissions associated with its construction, including the manufacture of its materials, which is the embodied carbon. Zero carbon ready building prioritizes energy efficiency. So that's reducing demand through passive design, high performance building envelopes, and high performance equipment. And it also considered the energy supplied that is supplied to it, and prioritizes locally available renewable resources. It is also a building that is integrated into the electricity grid through connected devices and automation to consume electricity at the most optimal times and provide a source of flexibility to the power system. And finally, it also considers the whole construction value chain in order to reduce its embodied carbon. This can be done through reducing material demand through material efficiency, like lightweighting or using alternative construction techniques, or using alternative low-carbon materials. These are all principles that can be integrated into building codes, which we see as the most effective measure to influence the design and construction of a new building. So for buildings globally to be zero carbon ready by 2030, building codes all over the world will have to start more effectively applying these principles. So as a picture of where we are now to show the scale of the challenge ahead when it comes to building codes, this is a map showing the status of building codes in 2018-2019. And this shows that building energy codes actually exist in only 75 countries, which is less than 40%. And only about half of these are actually mandatory for both residential and commercial sectors. So reaching zero carbon building codes by 2030 will need a significant effort in many countries, especially because developing the code is only one part of the challenge. They also need to be adequately enforced, and the supply chain needs to be ready. So this is where roadmaps come in. And we find the roadmaps approach helpful in terms of identifying a path from A to B. So while this might sound simple enough, actually getting consensus on the current state of play, on a common vision for the future and the roles and responsibilities for different entities is actually not always straightforward, especially in the building sector where there are so many different stakeholders, a fragmented value chain, but also lots of different ministries and government agencies involved. So this is why we see the development of a roadmap actually as a journey rather than a destination in itself. So the characterization of the current status, for example, is could include defining a quantitative baseline on the performance of buildings today. But there's often not enough data to be able to do this. But that doesn't mean that that other ways of assessing the current situation can't be done. So, for example, identifying the initiatives and the mechanisms that are already in place and that are already effective can also be very informative. And a note about a common vision. So it could be around achieving zero carbon buildings, but it might include other aspects too, that are interesting to different stakeholders. Can you still see my presentation? Okay, I'll carry on. So common vision might also include, as well as setting a target for net zero carbon buildings, it might also include other aspects of a target too. For example, a target for compliance levels with mandatory regulation, or the achievement of thermal comfort and affordable energy services for all, increased integration with the power system in order to achieve renewable energy integration goals, or a vision for more integrated governance across different ministries and across local and national levels. So these are all different ways in which different stakeholders might see value in achieving such an outcome. So at the IEA, we've been developing a methodology for developing building roadmaps. As mentioned previously, last year we released the regional roadmaps for Africa, Latin America, and Asia, as well as a global roadmap that we developed in collaboration with the Global Alliance for Buildings and Construction, and also over 700 stakeholders. And at the moment, we're also working on 2 more roadmaps, one that focuses on Southeast Asia in collaboration with the ASEAN Secretariat, and another roadmap focusing on residential buildings in India in collaboration with the Bureau of Energy Efficiency of India. And here we're building on the framework that was developed in the regional roadmaps and identifying more targeted and specific actions. So the structure of the roadmaps covers the entire value chain of buildings, from urban planning to new and existing buildings, appliances, systems and operations, materials, which is where we address embodied carbon, as well as resilience and clean energy. In each of these topics, we identify a vision, a strategy, an assessment of the current status, milestones and key actions, and best practice case studies. The process involves stakeholders throughout to get their validation on the content and on the targets, also to collect data through surveys, consultations, and capacity building. So this colorful slide is a snapshot of the summary of the strategies that we have developed, that we have proposed for the Southeast Asia Roadmap, which is still in progress. So this is a draft.
Maxine,
yes.
Maxine, excuse me, it's already 10 minutes, so just 5 minutes left for the time.
Sure.
Okay, thank you.
No problem, thank you. So I won't go into all of these in detail, but I wanted to show you the structure, an example of the structure that I've been mentioning. Here with the vision, which is in italics, and the elements of the strategy, which is in the white boxes. So if we take an example for new buildings, we have a vision of new buildings that are designed such that they enable higher levels of thermal comfort, energy efficiency, resulting in comfortable, affordable, and low carbon buildings. And the elements that we've identified so far as being key to achieving this vision is firstly, building codes, strengthening building codes and making them mandatory, increasing market demand for efficient buildings, and lastly, boosting capacity in the delivery of these buildings. So this is both in terms of skills, but also financial mechanisms and business models. And another little example that I won't go into fully here, but just again to show you how we're approaching these roadmaps, is that within each of these strategy elements, so for example, strengthening the adoption of mandatory building energy codes, we further break it down. And for each of the two elements here around increasing the strength and the coverage and then strengthening the implementation capacity, we have some milestones for 2025, 2030, and then a long-term milestone for net zero carbon. And we also identify specific actions to support achieving this part of the strategy, which is what comes below. And these are as specific as possible, grouped by stakeholder type where possible. And these are also strengthened and illustrated by examples from elsewhere to illustrate the successful approaches. This is the approach we're taking across each of the 8 themes that I mentioned previously. And at the moment, we're still working on the first draft and we're revising this draft. And we're still very much looking for input from stakeholders in the region. So building professionals in the region, like I'm sure many of the people connected right now. And we'd absolutely love if you could fill in our survey, which collects some information across the different themes around the current status of different technologies and policies, and also goes into a little bit testing what we've proposed so far. So I really encourage you to help us and contribute to this process by filling in our survey here. It should take about 15, 20 minutes. Yeah, we'd love to hear from you. So I'll stop here and I look forward to discussing further in the panel discussion. Thank you for listening. And yeah, please let me know if you have any questions.
Okay. That is very great, Maxine. Earlier, you are 2 minutes ahead of the runs out time. Thank you very much for that time management from your side. Okay. Maxine, it was an excellent presentation containing all aspects of the developing a roadmap toward net zero and energy efficiency. But I have a question as follows. Your presentation is very complete, starting from the CO2 emission and what is net zero building and where are we today, where do we want to get to, and blah, 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 blah. And the final conclusion, in one slide, you said that to strengthen the adoption of mandatory building energy codes, strengthen adoption of mandatory. So this roadmap mentioned that the adoption of the building mandatory is one of the success factors. In many developing countries like Indonesia, if you have the mandatory with a stringent regulation of codes, especially if also with the law enforcement, usually is a less popular regulation and are generally avoided even by the government in preventing the resistance to the government which is in the power currently. In your opinion, what is the government strategy in drafting the regulation to support your statement about adoption of the mandatory regulation? So what is the government strategy to have the highest probability of success and can be accepted by the relevant industry? That is my question. Please, Maxine.
Thank you for your question, and it's a difficult one because as we saw from the map that I showed in my presentation, there are still so many countries that don't have mandatory building codes for at least for both parts of the sector and even for sometimes at all. But I think there are a couple of key points that I would suggest in response to your question. I think the first one is just a recommendation to actually just make it mandatory. There's evidence to show that if you have an integrated approach with an integrated policy package of which one of them is a building code, making it mandatory, unless it's made mandatory, then it probably will not get complied with. And if it's made mandatory, the market will adapt in time. I think if there's uncertainty, then industry may not make may just wait and not get ahead and prepare. And in terms of, as I mentioned, a complete policy package, I think that's also another key area. So building energy code really is about limiting the minimum. It's like a minimum performance standard for buildings, but integrating that in a policy package that actually firstly ensures that there's a compliance mechanism in place to check whether it's being enforced, ensure that there are delivery mechanisms in place, such as capacity building, financial mechanisms and incentives. And again, if you do the capacity building first and the finance mechanism first, but the code isn't mandatory and there's not the demand for more energy efficient buildings, then no one will take those up. So that's why it really needs to happen at the same time in an integrated approach.
Okay.
And that also helps to ensure that there's a market for the skills that are being introduced and the people that are being trained. If you train a whole load of new building designers, but there's no market for them, there's no demand for those skills, then that'll be a vicious cycle, and that won't be sort of optimized. And I think the other area, the other point about in an integrated policy package is around having transparency around where the code will be going. So starting with a sort of simple but mandatory code, but showing very clearly where that's going to go and where that needs to go and what kind of timeline would help industry prepare. And I'd say one other point is around collecting data around additional cost, around the sorts of measures that are most effective, most cost effective, collecting all sorts of data around the benefits of implementing such a policy helps not only with continuous improvement and adaptation of the code through the cycles, but also it helps gather an evidence base for dialogue with other stakeholders and show that actually there's a lot to gain from having strong regulation for low carbon or zero carbon buildings.
Yep. Okay, thank you, Maxine, for all the information and the answers that you provide, and also thank you for the material you share for us. This is because due of the time limited, then we have to jump to the next speakers. So thank you again, Maxine.
Thank you very much.
Yep. Now we continue listening to the speaker from the property sector, from the building sectors. As Maxine already mentioned, that we're talking about a net zero energy building, then we have to know about what is the comment from the building and property sector. So as the second speaker, Mr. Ignesjz Kemalawarta from Sinar will give the presentation with the topic of decarbonizing building construction. And please allow me to read his biodata. He graduated from the bachelor degree from Architecture Institute Technology Bandung and master from Newport University, USA. Now he is a director from the Sinar and also a vice chairman of Real Estate Indonesia, vice chairman of the Kadin Property, and also vice chairman of the FIAPSI Indonesia. Active in Green Building Councils Indonesia from 2013 until 2018, and always acting as a lead GP in the Greenship certification process for the buildings which owned by the Sinar land. Now is the time for you, Mr. Ignesjz, to give the presentation. Please do so. And again, the time is very limited. Please, not more than 15 minutes. Pak Ignesjz, the time is yours. Oke. Ya Pak, silakan Pak. Bahasa Indonesia oke, bahasa Inggris oke. Silakan Pak Ignesjz. Ya Pak Ignesjz. The time is running.
Oke, ya sudah dengeran Pak ya?
Kedengeran Pak. Ayo Pak.
Okay, so the agenda which I will present is for the main reason why we need the energy saving and low carbon development. The second is the decarbonized understanding. for the building sector. The three is what Sinar must do towards energy saving and low carbon development. This is the practice that we do right now. And then the photovoltaic use in BSD Green Office Park towards net zero ready and other use of photovoltaic in other commercial buildings. Yeah. So this is the three reasons. So that the big reason is energy scarcity for the future. Yeah, we know that the reducing of climate change to reserve energy for next generation, and also our renewable energy is still very low according to the capacity that we can do. Yeah, this is the fact. Then the second big is need carbon reduction from building construction. First is from carbon material embodied. Yeah. And then second from the material transportation itself. Understanding is there is a strategic steps to reduce carbon building through two parallel ways. So first is reduce energy resources towards renewable energy and energy saving program. The second is reduce carbon embodied materials used in the building construction. So what we do then, yeah, coordinate mass action. Yeah. First is green district development. Second is green building towards net zero ready. The third is green habit program. Four is energy competition. 5 is embodied carbon material reduction. 6 is towards low carbon development in the area, because we developed 6,000 hectares of new townships. So this number 6 is very important then. So the green district is we are doing the green mark in 2011 for the Green Office Park, and now we are doing the Green Ship Naval Park, still in process. So in this session, we discuss about centralized drainage, photovoltaic street lamp, and then microclimate, and so on. Yeah. So after that, we developed the green building. We developed about 6 to 7 buildings now in BSD and Deltamas. Yeah. So the main result is we get the energy efficiency range 30 to 40%, yeah. And also water efficiency 25 until 40%, reduce carbon emissions 600 to 1,000 ton per day. Yeah, another benefit, yeah, for healthy building and so on. This is the list of our buildings. So yearly we get the emission carbon reduction from 1,000 ton per year, yeah, 100 ton or 89 ton per year, and so on. Yeah, and also the low energy index, yeah, every building. By then we get almost the building in DOP get the ASEAN Energy Award, yeah, National and Asian Energy Award, almost all the building. So we think that we have 3 stages, yeah, from the planning, from the design recognition, from the certification itself, and then the red color is green habit to maintain and increase energy and water saving after we get the efficiency from the green building itself. It is responsibility from building management and building occupant. So we don't let building occupant to run alone, but we give some guidance. Yeah. So it consists of launching, campaign, and program. Yeah. So this responsibility again to building management and building occupants. Yeah. So we do a campaign, newsletter, education. By these people every day look at this sign, so they're boring and they change their behavior, maybe, hopefully, yeah, like that, to the better behavior. Then education newsletter to everybody can reach this through the computer. Yeah. So we get the result after the saving of the building. So average 20%, because there is some people who only 7%, some people only get 33%. Yeah. And this is from the lighting. Yeah, and so cover 20% of the all energy of the building. The blue color is for the air condition. So green color we get such kind of percent. Yeah. So the intangible result, yeah, people using the stair, yeah, people doing the more habit, ask for the more hot temperature. Formerly they get 18 degree, 20 degree, but now they usual with the 24 degree of Celsius. Yeah. This is the move of the habit from the building occupants. And also from our building in Sinar Marsland, we get something like a competition. Yeah, we divide into 3. So the low building, so about 5 building, about the middle building, and the high building. High building is like Sinar Marsland in Tamrin, which is 28 floors. Yeah, so we count energy of this building every year, and then we count and we like remind them, please get the more safe energy for the years and so on. Yeah, so this I think it's good because people seem that we have to do more saving in the future. Yeah. This for the embodied carbon reduction, we fairly speaking, we still in the planning. So we will select for low embodied carbon through green certificate material that we use in the green building. So we will select this material, and then we choose the low embodied carbon, which is also a reasonable price to implement in all Sinar Masland project. We will start this this week, and then will become our policy then. Yeah. And also I used to buy our material with the low distance in order to reduce the carbon footprint. Yeah. For the low carbon development, since we developed the new township, we are realized into the four key. Yeah. First is to realize about the waste program. So we look for how we do the better waste program, which is reduce also CO2. The liquid waste, second. The third is energy. The red box is that we discussed before for the building, office. All building will be reduce energy, but we have to expand for the LPG use in houses, and then gasoline for cars, and another, and then the fourth section is for the additional green space, because we continue additional plantation tree and make it much more in BSD, to absorb the carbon. So this is we start develop to about 2,000 hectares area for the delineation for BSD. So for the green building, all green building, the 195,000 carbon has been reduced. The way we do is to combine passive effort and active effort. So the site microclimate, landscaping, orientation, OTTV, hardscape materials, and natural lighting maximization is become to passive effort, while the active effort consists of maximize performance of equipment, AVAC, low kW per TR, test and commissioning, electric metering, low flow water tap, water recycle, and sensor. So we combine those two efforts to get the maximum energy saving in the green building and continue again in the green habit program. So for the green building, one building we test for the using additional photovoltaic in all the roof. So this is in GOP 9. In GOP 9, we get the platinum for it. We add the photovoltaic. Formerly is grass, rooftop grass, but we think that it's better if we change the grass with the photovoltaic, so that we can make another energy addition for the building. So the capacity is 154 kWp. So the saving is like this. So this is the figure that we get the energy saving from the green ship energy calculation. So we get 36.5% from the all energy efficiency. So in addition with the photovoltaic, we get about 52.4% at the whole. This is our effort into the most of commercial building to set the photovoltaic. This is the sample for the Unilever building. This is the sample for the cubic commercial building. It's also good in energy saving. In the middle is for the marketing or old marketing office, and also in the right is for our customer service office. So all of the roof we try to get the photovoltaic in order to reduce the PLN energy. Then we also use the photovoltaic in street lamp with GOP. Then some place we put the happy charger station, cooperation with Sun Energy.
Ignesjz.
It is the construction, Rana.
Yeah, this is the first signal.
Yeah.
Already. Oh, this is the last slide.
Yeah, that's it.
Oh, that's great. Yeah.
The last slide. So I think that building
excellent.
With the energy saving program as well as low carbon embodied program. towards net zero energy and net zero carbon. So Sinar Masland has started to develop building energy efficiency through widely implementation of green building and start to reduce carbon embodied material in building material and construction. So together with widely use of photovoltaic in commercial buildings, that what we do until now. Yeah? So our suggestion is government should give incentive to photovoltaic production so that it can be delivered to building industry with lower cost, because now it's still higher cost. Yeah? In order to increase utilization of renewable energy to meet national target. And the last is there should be intensive socialization to all building industry actor to do both energy efficiency and use embodied material in building material used in the building construction. Yeah, I think this is 5 key for our conversation, Rana. Maybe we can go to the question and answer. Yeah, thank you.
Okay, excellent. Because you still have you are ahead of the minute. That's very great. That's very great. So thank you very much. And it was an excellent presentation. And you gave a picture from the developer's point of view on the building sectors about the net zero energy building target and the building energy efficiency. And also it means that's already proven that building industry is ready and has a positive way in response to go to the net zero energy building with a some approach that already shown by Sinar Masland, your company. My question is like this. 1, many companies are reluctant to implement the green building concept, including energy efficiency, because it is considered to be more expensive. Question is, how does Sinar Masland can manage to overcome this issue, even proven that many of your building has been certified as a green building? That's my question. Would you please do answers on?
Can I back to the presentation? So just
sure.
The sharing. Sorry.
Yeah, sure.
Okay.
Just share screen.
Okay. Yeah. Okay. First thing is in Sinar Mas there is a value of the group. Yeah. So we have to develop something that in our project. Yeah. Something that commercially wise, so that we can get profit for that for our life. Yeah. Second is environment side. The third is social side. So those 3 aspects is become our philosophy in Sinar Mas. Yeah.
Yep.
So environment is we propose environment is become something that can become a comparative advantage for us, so can bring our value. Yep. by developing the environment. Of course, in developing green building there is additional cost. Yeah. But in our experience, the additional cost is cover about 4% averagely. So we have to clear about sometimes we think about this is more expensive, yeah. And then we have to separate that it's not expensive because of the choice of luxury material. So it's expensive because of some important thing that should be added into the building. So let's concentrate about what we have. Usually we add in the building, yeah. So in the blue box, there is a good glass to reduce heat. So usually we use this for reducing heat from the outside to inside. So reduce air condition by kW per TR, which is lower. Reduce energy saving lighting, yeah. Reduce water. We use water recycling to reduce paid water use from the government. Low flow rate water fixture, and then sensor lighting or move, and then separately pays for buying system. So by investing our money in the blue box, yeah, we of course we get the more expensive, but in return in the operation stage we get the saving in operation. So can be back more faster than 5 years, and then after that we sure we enjoy the saving of the operation compared with non-green building. Yeah. So if you want to, Pak Rana, remember that we in green building council we develop also some book that prove that some building have additional investment cost, but get also in return the efficiency of the infrastructure. Yeah. So everybody can get this link ya. So this is two sample, Gedung Kelautan dan Gedung PUPR ya. And then we can pass through this link to get the information.
Yeah.
I think this is the answer, Pak.
Yeah, okay. So that means you already applied the LCCA analysis, right? Life cycle cost analysis, which is most of the developers doesn't want to do to more invest. But you do that with the confidence that you will get the earning from the less on the operating costs, right?
Yeah, yeah.
Okay, great.
And of course, in the to buy something, we also try to look for the lowers also, not at any cost, yeah.
Yeah, sure. Yeah, of course. Yeah. Okay. Okay. Thank you very much. Thank you, Pak Ignesjz, for your presentation, which is very useful and give us pictures from the building sectors, especially from the property sectors. Okay. Thank you again. Now we come to the third speaker, which is Miss Virginie Letschert from Lawrence Berkeley National Laboratory in USA, with the topics of efficient and climate-friendly cooling opportunities for Indonesia. She talked about especially for Indonesia. And following, allow me to read her biodata. Ms. Virginie is a researcher at Lawrence Berkeley National Laboratory with over a decade of experience in energy efficiency policy analysis and international program development, and leads international collaboration and technical assistance activities. She has collaborated with the government of Indonesia since 2015. So no wonder she knows about Indonesia and take this material presentation about the Indonesia, focusing on appliance energy efficiency and energy demand modeling. Okay, Ms. Virginie is not with us in this virtual breakout session. She is still abroad because she is in USA with a big time difference. Right now, I think in USA is still early morning. So for her presentation, she will give presentation by a recorded video. So for the organizers committee, Pak Salim, would you please to ask to the committee to run the recorded video from the Virginia, please.
Good afternoon, everyone. I'm Virginie Letschert. I apologize for not participating live in this conference. This is a recording of my presentation. But feel free to contact me in the future if you have any questions. So today I'm going to talk about an opportunity for Indonesia to transition towards more energy efficient and climate-friendly cooling technologies. I work for Lawrence Berkeley National Laboratory, which is a laboratory part of the network of the US Department of Energy. We work with the government of Indonesia since 2015. This collaboration started under the Clean Energy Ministerial, and we focused most of our work on appliance efficiency and also energy demand modeling. We work all over the world, specifically on cooling. So recently we've helped China with the development of their maps for air conditioners, and also UN Environment with the United for Efficiency initiative to develop model regulations. And I will talk more about that in the next slides. All of that to help leverage the market transformations toward inverter air conditioners and low GWP refrigerant or climate-friendly refrigerant. We are a key partner in the Kigali Cooling Efficiency Program, KESEP. We worked in all over the world supporting market transformation program, so the maps, labels, and also complementary program. We work in Brazil, in Mexico, in Egypt, in South Africa. And recently, we've been awarded a project under KSEP to support the ASEAN region, and I will talk about it in this presentation. In the past, we also worked directly with India. There was a US-India space cooling collaboration, and we helped them with the latest, the maps, 2016 maps, and also with the development of their first bulk procurement program. Why focusing on air conditioners? As you can see on the left side here on the chart, we've done some work on forecasting the load curve in Indonesia, and you can see how the peak demand is the one that's really growing very rapidly. The government of Indonesia also recognizes that and is planning to add about 56 gigawatt of new generation capacity by 2027. That new generation is mostly thermal. Our research on energy efficiency has shown that we could reduce the peak demand by 10 gigawatt by 2025, thanks to energy efficient technologies. Out of all the policies we're looking at, air conditioner is the one that by far has the most impact. This is due to several factors. The first one is that this is an end use that's growing very rapidly at 7% a year. It's also due to the peak coincidence. So most of the ACs are used at the same time, and they are actually creating the peak. And we estimate that in 2025, 30% of the peak will be due to air conditioners alone. On the other side, there's a strong technology opportunity with inverter technologies that are much more efficient than the traditional ACs. So there is really a great opportunity for Indonesia and for ASEAN to transition towards energy efficient and climate friendly technologies. This is due to a global transition. So this is a transition that we've seen happening already in the past in Europe, in the US, Japan, Australia. You can see on the left end of the graph here, the blue bars means that the market has transitioned pretty much entirely to inverter AC technologies. Also, they've transitioned to HFC. You can see that in China that happened all over the last 10 years, but that in 2020, we have the data showing that almost all the market has now transitioned to inverter ACs. So it's very, a great example of market transformation, where they went from 20% 10 years ago of inverter ACs to 100% here. And so this has been mainly driven by policy. You can see that the rest of the world is still in the middle of that transition. And so that's why we need the policy to help support and accelerate this transition, given all the benefits that are associated with inverter ACs. You can see Latin America, Middle East, and Africa are around 10% of inverter ACs, whereas in Asia already we see about 40%, depending on the countries. So yeah, a great potential to phase out those inefficient high GWP ozone depleting refrigerants. And so I wanted to show you some data on that transition with an example in Japan, and specifically talking about price. So it's not in every country. We do not have that much of a rich data set to track down the price over time. But in Japan, we do have that. And so what you can see here is that the Japanese Top Runner program has been incrementally increasing energy efficiency. So that's the yellow line here. You can see it first starting in 98. And you can see the effect of the program on the energy efficiency in the market. But you can see that at the same time, the blue line here, a sharp decrease in price as efficiency was going up. So This is just to show that it doesn't mean, even though you are increasing energy efficiency, it doesn't always mean that the prices will increase as well. So in terms of international policy trends, we've tried to show you here the latest updates focusing on major economies. So you can see here where ASEAN stands with their roadmap, the 2020 targets. So it's around 10 CSPF. And you can see that above that, so the Japanese top runner program has been a lot higher for the last 10 years, because since 2010 they have that target at 15 CSPF. You can see where the US stands, Korea maps, so all around 15. And you can see also the 2022 India maps, that's about 20% above the ASEAN levels, current ASEAN levels. Then above that, you can see China. So China is the country with the most stringent maps at the moment. You can see that by 2022, they will merge the fixed speed and variable speed categories. So inverter ACs will be considered in the same category as the traditional fixed speed. And so we expect that will finalize the transition towards the inverter ACs. And also the U4E model regulation. So those are same level as China, but we recommend that they would be adopted later on. So here we have like 1 year to give time for prices to come down. So 2023 is the recommended year by default to adopt the U4E model regulation, but we'll see later that for ASEAN we recommend actually 2025. And lastly, I wanted to draw your attention on the global best available technology. So that's the result of a recent competition, and you can see that there is still a lot of room for improvement, even for the China maps. That's already the best practice in the world. That even with that, there is still a lot of room for improvement, and that the global best available technology is around 35 CSPF, and so that's basically a technical potential currently, and that we can expect that in future years that keeps going up. So if you are interested in learning more about the U4E model regulations, I'd like to invite you to go on the U4E website. So it's the unitedforefficiency.org website, and under resources, you will be able to download those model regulations along with a lot of other resources. So the idea with those model regulation is really to help countries adopting new or to update their maps and energy labels, to help them not reinvent the wheel and help them harmonize with best practice policies. Existing regulations that are proven, that are robust, and that can be implemented more easily. They've been designed to target at the same time energy efficiency, but also having a criteria about the low GWP. So that will ensure that the regulation covers both aspects and that you will get, in the end, energy efficient and climate-friendly air conditioners in the market. So there are a few opportunities for harmonization for Indonesia. The first one is with ASEAN, because ASEAN is in the process of revising their roadmap target for the first time since 2015. In parallel, Thailand and Vietnam are revising their maps at a level that's about 20% higher than the current levels, and so did India with their future maps in 2022. The other opportunity is harmonizing with China, the Chinese maps and the U4E model regulation. we expect that this MEPS is going to drive down the cost of air conditioners, inverter ACs in the next few years. And the U4A model regulation have already been adopted by some countries and are being considered by other countries around the world. There are a few projects on the way to support ASEAN with their harmonization. The first one is a project funded by the Japanese government and implemented by ACE and IIEC. There will be different work package and they are in the first phase at the moment. The outcome of this project is a roadmap for ASEAN that considers two targets. The first one in 2023, 20% above the ASEAN Shine target level. And then the next one in 2025 that's harmonized with the U4A model regulation. And then you have the KSEP project that will provide some technical assistance to the region and to certain ASEAN countries to help them adopt the roadmap. And that's in collaboration with U4A, IIEC, and ACE. So as part of the ongoing efforts, IIEC has collected some data on the AC market in Indonesia. And so you can see some very interesting findings here, very recent. The first thing is that the inverter share is going up. So this is based on number of models. We find that 28% of models are inverters now. So that's gone up since the last time we were working in the country. Another fact that's very important to understand is that the local production is actually very limited. Most of ACs are imported into the country. So 84% of ACs are imported. And so there's a great opportunity for Indonesia to increase this local market share and reduce imports. Even greater opportunity is that we find out for the first time that Indonesia is producing inverter ACs in the country. So this is the graph to the right at the bottom here. It's just a small fraction, but it means that that there's a great opportunity for local manufacturing to increase their market share. So it used to be that all inverters are imported from Thailand and Malaysia principally, but now Indonesia is able to produce their own inverter AC. So that's really a great news, for local manufacturers, for the country to reduce the imports. But also you will see at the end of the presentation the benefits for consumers and all stakeholders from more efficient technologies. So I wanted to talk about costs again. We do have data for Indonesia from the market back in 2016, 2017 that we hope to update as part of the current project. But already at the time, we could see that the difference between the low efficiency products that are towards the left end of that graph and the products that are around an efficiency of 12 to 13 CSPF, you can see that the incremental cost is very low. It's actually in a whole distribution. And when you really look at the minimum cost to upgrade for efficiency, it's a very low incremental cost. You can also see that the green square here, you can see that all of these are inverter and that they were already available on the market at the time, and there's quite a lot of them. And so we expect that in 2021, what we'll see is even more of these, and that costs have come down as well due to economies of scale. So for this reason, we are making the following recommendation. So you can see here the current ASEAN Shine target, the 2020 target. So we are recommending that Indonesia would harmonize with the rest of ASEAN to maintain its competitiveness in the region. So that's at a level that's 20% more efficient. And you can see it's pretty much equivalent to the India maps from 2022. And then by 2025, we expect that cost will have come down even more significantly, and that Indonesia and the rest of ASEAN will be able to adopt the U4A model regulation, equivalent to the China 2022 standard. So that's 2025. And then you can see this, we've identified 3 other levels here just to show you the remaining potential. So those could be targets for label, for example, for voluntary programs, but you can see there is still a lot of room above the China 2022 target. So this one is a summary of an analysis that we did in 2020. So it's an older project, but it's to give you an idea of the magnitude of the impacts from this regulation. So we look at the consumer, national, and manufacturer impacts for Indonesia. So you can see we looked specifically at the revision of the ASEAN target at a 20% upgrade. We looked at the China MAPS U4A regulation, and then at the highest level of the U4A regulation for a label, for example. And so you can see that all of them have very positive impact, a lot of benefits for the consumers that see a life cycle cost saving with very short payback period, so all less than 3 years. And then when you look at the national level, the impacts are, very high. So for example, you can expect around 20 terawatt-hour of savings by 2035 with the adoption of the China 2022 MAPS. In terms of peak load reduction, if the U4A model regulation is adopted, we expect around 3.5 gigawatt of reduction by 2035. Net present value in million US dollars. So here, you can see very positive impact. Even with just the ASEAN shine or the ASEAN target at 20%, you see almost 1 billion or over $1 billion of positive impact, and then it just keeps going up as you go up in those programs. The last one is the local industry impact, and so you can see again that even though it's been a concern in the past that MAPS can impact negatively the industry, this is not the case. This is not the case here. What we have identified is that the incremental cost that will fall on local manufacturers to retool their equipment actually is recuperated very rapidly by the sale of new products that are more efficient and that have an incremental cost. So they recover their cost and they see a benefit. And that's, assuming constant market shares. But as we saw, there is an opportunity for local manufacturers to actually increase their market share by reducing imports. If local manufacturers start producing inverter ACs, it means that less inverter ACs are imported from Thailand, from Malaysia, and from China. So again, a great opportunity all around with a lot of benefits. And I invite you to look at our publication to see all the details of the analysis. It's available on our website. So finally, our conclusion recommendation. So we recommend that by 2023, Indonesia harmonize with the other major economies of ASEAN by adopting a MAPS that's 20% higher than the current target. By 2025, we recommend that Indonesia and all the other member states align with the U4A model regulation that's already completed by China and also considered by other countries. That economies of scale are already driving down the cost of air conditioners, inverter ACs. So that's something that we already see in the data from China, because China has already transitioned to inverter ACs, and that because they are the main manufacturer for the world, that already costs have come down. And just a reminder, something like a takeaway is to keep in mind the magnitude of impacts of such policies, on the peak load, so reducing investments in new generation capacity, on CO2 emissions, while at the same time showing a large benefits from from these policies for the Indonesian consumers, but also for the local AC manufacturers. So with that, I want to thank you for your attention and invite you to check our website. And if you have any question, please do not hesitate to contact me. I'm sorry not to be here in person again. But yeah, do not hesitate to contact me. I'll be happy to answer any question. Thank you.
Unfortunately, Virginie takes about 25 minutes, and we cannot stop her because it is a recorded one. So we have to be patient until it finishes. So I think there's will be no question right now for Virginie, except I will email to her about that, and then I will distribute to all you, the participants, via email. The problem is that most of the consumers, especially in Indonesia, are concerned about the price. I think they just only considers a little bit about the efficiency, especially if we talk about the CSPF, cooling seasonal performance factors. Consumer doesn't know about that, so we have to increase for learning, to increase the knowledge level of the consumers. Okay, so that's my point for the Virginie. So thank you, Virginie. You are not here, but thank you very much for your findings. Now we come to the last speakers. Mr. Dany Watanabe from Berca Carrier Indonesia will deliver the presentation of building energy management system for the futures. It is quite interesting to know the comment from the chiller manufacturers, and this is his biodata. He was graduate as Magister Technic from University of Atmajaya, 2017, and he is a Greenship Associate Certified and Greenship Professional Certified from the GBCI. He has worked at many companies from PT Asbil, Daikin Indonesia, Train Indonesia, Johnson Control or YOK, and joined PT Berca on January 2020. And now he is a Plan and Specification Manager. So it means that Mr. Dany has been working with all four big guys of the chillers industry, Train, Daikin, York, and Carrier. Okay, now is the time for you, Mr. Dany, to give the presentation, but please do remember not more than 15 minutes. We are already almost run out of the time.
Okay.
So the time is yours. Ya.
Baik Pak Rana, saya coba menggunakan udah lihat. Kira-kira Pak Rana sudah tampil ya?
Sudah tampil. Oke, let's start it.
Oke. Baik, agenda di sore hari ini saya akan menjelaskan satu untuk company profile dari Berca Carrier, yang kedua ceramic bearing teknologi, yang ketiga high power refrigerant 1233ZD dan falling film evaporator. Tentunya dengan teknologi ini impact-nya adalah di energy saving dan CO2 emisi reduction. Dan terakhir saya akan berikan beberapa summary-nya. Nah, Berca Carrier Indonesia ini the inventor air conditioning modern pertama di dunia, yaitu ditemukan oleh Willis Carrier. Dan Berca Carrier Indonesia atau Carrier sendiri sudah berdiri lebih dari 118 tahun. Dan di tahun 1999, Carrier beserta dengan Toshiba Corporation, yang kita tahu Toshiba sangat besar juga marketnya untuk residential unit, VRF ataupun split atau multi-split, melakukan joint venture, sehingga saat ini kita pun sebagai pemegang merek dari Toshiba Air Conditioning. Hal ini untuk memperkuat market dari segmen untuk air conditioning large tonnage dan juga di residential unitnya. Di 2014 kita juga punya big project ya, seperti di Singapore Changi Airport, kita sudah melakukan 60 unit lebih chiller, baik itu centrifugal atau tri-rotor. Hal ini menunjukkan bahwa Carrier sanggup untuk melakukan dari tahap design, planning, sales, dan juga after sales, karena kita memiliki banyak solusi untuk air conditioning dan juga after sales dan juga kontrol yang kita miliki. Nah, di Berca Carrier Indonesia di tahun 2014 establish, yaitu melakukan joint venture antara Berca, kita tahu grup lokal yang besar juga di Indonesia, dengan Carrier Corporation USD. Oleh karena ini, kita melakukan sekarang establish dengan nama PT Berca Carrier Indonesia. Kita memiliki visi menjadikan Indonesia tempat yang lebih baik, dan misi kita menjadi pertama memberikan solusi air conditioning di Indonesia. Nah, saya masuk di dalam latar belakang kenapa centrifugal chiller itu sangat difokuskan ya. Yang pertama karena kebanyakan 80% building itu tipikalnya large building. Ya, seperti kita tahu ada hotel, high-end office, hospital, data center, dan proses dari industri cooling itu sendiri. Hal ini akan berimpact terhadap energi di building itu sendiri. Kita bisa lihat beberapa energy consumption di building seperti dari vertical transportation, airside, dan low energy consumption lainnya, lighting, tetapi 45% itu disebabkan dari chiller plant itu sendiri. Di mana tadi sebelumnya chiller plant itu terdiri dari chiller yang sentrifugal yang saya sampaikan, lalu ada pompa, begitu juga cooling towernya. 45% energi dari building menyumbang kontribusi impact terhadap lingkungan ataupun juga global warming potensial itu sendiri. Nah, chiller plant salah satu juga penyebab dari global warming. Oleh karenanya, kita berusaha untuk melakukan desain ataupun optimize dan tentunya mencari teknologi chiller terbaik supaya bisa mereduction dari power input dan emisi gas CO2 itu sendiri. Nah, di sini saya coba sampaikan yang dimaksud dengan building load profile. Terkadang penghitungan dari power input atau energy consumption dari HVAC itu sendiri menggunakan sistem full load ataupun juga generalnya IPLV. Nah, tetapi di masing-masing building seperti yang saya tampilkan, baik itu hotel, kita bisa lihat di grafik di atas ini, hotel hampir dikatakan 24 jam melakukan sistem pendinginan ke ruangan-ruangan. Tetapi kalau kita lihat juga di mall, mall ada namanya starting dan off untuk operatingnya. Nah, di sini kita bisa lihat kalau hotel cenderung dia melakukan namanya tiap jam ini, kalau dia berjalan misalnya pagi, dia rendah, lalu nanti dia naik di 10 jam 12, dan berikutnya jam 2 ketika orang sudah check-in, dia mengalami peak load-nya gitu. Lalu dia akan turun lagi dengan malam. Nah, kenapa itu beda? Karena ada activity yang berbeda di hotel itu sendiri. Nah, kalau mall building dia cenderung seragam, dan office building dia cenderung melakukan namanya starting di lower, baru middle, peak, dan juga akan turun ketika nanti jam sore ataupun overtime-nya. Nah, dari data per jam ini, itulah yang kita hitung berapa konsumsi energi, khususnya di chiller plant itu sendiri. Ceramic bearing chiller, teknologi yang dimiliki oleh Carrier saat ini, sudah tidak menggunakan sistem lubrikasi oli, ya, karena oli itu bisa menyebabkan namanya kebocoran, related maintenance, oil related maintenance, dan hal-hal ini pun oli ini akan impact terhadap lingkungan dan juga kita bilang ekosistem di Indonesia. Dari tampilannya, ceramic bearing ini itu terdiri dari high nitrogen steel, lalu bearingnya memiliki ceramic rolling element, dan kekuatan ceramic bearing ini sudah dites berdasarkan United Technology Research Center Wear and Test and Carrier Chiller Reliability Test dengan running 120.000 jam lebih, artinya bisa 30 tahun melewati dari kondisi normal centrifugal umumnya. Nah, di dalam sistem lubrikasi ini, itu ada impact di exploration. Kita tahu ada proses penambangan di sana yang dapat menyebabkan kerusakan, baik itu di land atau marine ecosystem. Di productionnya sendiri, tumpahan-tumpahan dari oli itu menyebabkan kontaminasi, baik itu ke air, ke tanah, dan juga bisa menyebabkan kebakaran juga. Dan di transportasi ini saya ambil sumbernya di tahun 2018 dari US GHG emission, sektor di Amerika transportation itu terbesar 28%. Nah, pembakaran dari bahan bakar fosil ini itu akan menyebabkan karbon dioksida dan gas rumah kaca itu ke atmosfer. Desain dari ceramic bearing ini pun tentunya tidak hanya di ceramiknya, kita juga mengimprove di sisi evaporatornya. Di sini sudah menggunakan R1233ZD, dengan kita lihat perbandingan antara flooded sebelah kiri dan falling film sebelah kanan. Ketika flooded, semua refrigeran digenangi di sisi dari tubing itu sendiri. Sedangkan di falling film, dia menggunakan sistem spraying, dan spraynya tersebut itu akan fokus di sisi dari tubing itu sendiri, sehingga dia less refrigerant charge dan juga better efisiensinya. Saya kasih lihat di slide berikut ini, kita punya chiller juga tipe flooded yang centrifugal chiller. Ini kita seleksi dengan kapasitas yang sama 500 TR. Di kolom atas ini, data atas ini tipe flooded evaporator. Itu kita bisa lihat refrigerant weight-nya itu 1.629 pound. Sedangkan falling film evaporator type, refrigerant weight 846 pound. Hal ini membuktikan bahwa sistem refrigerant yang menggunakan falling film evaporator teknologi ini bisa reduction 48%, yang dimana ini sangat mendukung terhadap lingkungan dan tentunya di LEED Credit 6 untuk version 4-nya. Untuk refrigerannya sendiri, kita sudah menggunakan 1233ZDI. Tentunya untuk ODP atau ozone depletion potensialnya sudah 0 dan global warming potensialnya kurang dari 1. Dan kita bisa memiliki efisiensi yang lebih better dari 134A 5%. Dan R1233ZD ini sudah dapat grade A1, yaitu low toxicity dan non-flammability. Dan untuk isu pace down seperti yang dialami 134A starting di tahun 2024, di Kigali Deal ini tidak mengalami isu Kigali Amendment. Dan juga di dalam Material Resources Cycle Green Building Council Indonesia versi 12 2018, dia juga sudah comply dengan refrigeran yang ramah lingkungan dan juga rendah global warming potensialnya. Lalu di sisi konstruksinya,
Pak Dany, mohon maaf,
ya.
Waktunya tinggal 3 menit lagi, Pak.
Oh, baik Pak, baik.
Ya, terima kasih.
Saya cepat saja. Di sini kita lihat konstruksinya, di sini ada motor di tengah dan kiri kanan sentrifugalnya, dan ini direct drive sehingga kita less aeropaths. Saya coba seleksikan. Jadi ini ada performance report dari 550 TR centrifugal chiller. Kita bisa lihat efisiensinya di full load sudah 0,5, 0 di bawah, 0,48, begitu seterusnya. Dan saya compare dengan ASRE 90.1. Compare ini baru membuktikan 550 TR satu chiller itu didapat, Mbak. Untuk sisi full load-nya compare ke ASRE 960.960 kilowatt, sedangkan IPLV yang ASRE 1 juta, dan carrier ceramic bearing 825.396 kilowatt, sedangkan di sini di full load kita hemat 135.564 kilowatt, dan IPLV integrated part load value 190.476 kilowatt. Hal ini kalau kita convert dengan emission grade per tahunnya, dari sisi full load saving untuk reduction-nya 14% dan untuk integrated part load value-nya 19%. Nah, kalau dilihat selama 20 tahun lifetime dari chiller itu sendiri, maka di IPLV ini kita bisa saving 3.809 kilowatt. Dan bisa dilihat untuk emisi CO2 reduction-nya 3.394 ton selama 20 tahun lifetime chiller itu sendiri. Nah, sebagai summary, di sini saya sampaikan sekali lagi, ceramic bearing chiller itu sangat bagus di sisi untuk low global warming potensialnya, yaitu dia tadi kurang dari 1 sehingga menggunakan R1233 ZDI, dan untuk emisi karbonnya kita leading efisiensi, dan terakhir support untuk sistem upgrade energi efisiensi. Jadi tidak hanya chiller, kita juga bisa upgrade sistemnya dengan pompa, cooling tower, dan sistem kontrol ke building itu sendiri. Nah, di sini beberapa proyek yang sudah kita pasang, successful project kita ada di Veron 700 dan 500 TR, Pondok Indah Mall 3 800 TR kali 5, Raja Wali Place 600 kali 3, 800 TR kali 1, Garuda Maintenance, Ciputra Watt Surabaya 750 TR kali 4. Dan juga ada Project N, ini NDA juga, data center 700 TR kali 6, dan Entex Parindo Asia. Terima kasih sekali lagi Pak Rana atas waktu dan kesempatannya. Sekian dari saya.
Ya, oke. Terima kasih Pak. Terima kasih banyak ke Pak Dany. Saya pakai bahasa Indonesia aja karena you are speaking in Indonesia, oke. Jadi thank you dengan informasi tentang the last chiller technology yang sangat baik. Pertanyaan dari saya begini, kita tahu dari dulu efisiensi chiller makin lama makin baik. Kalau dulu diusahakan dengan memperbesar evaporator dan kondenser sampai satu saat berhenti karena sudah sampai kepada commercial price consideration, kemudian pindah kepada bearing sekarang. Bearing untuk bisa mengecilkan friction sehingga kemudian bisa tambah efisiensi naik. Pertanyaan dari saya, kira-kira on the future, very near future, kira-kira teknologi apa yang akan dikembangkan, ke arah mana teknologinya, supaya kita mendapatkan chiller yang jauh lebih efisien daripada yang sekarang. Terlepas dari size daripada heat exchanger, terlepas dari masalah bearing, kira-kira kemana larinya, supaya kita bisa mencapai global sustainability dan ultimate efficiency from the cooling aspect. Ya, silakan Pak. Singkat aja jawabannya, Pak.
Oke, baik Pak Rana, terima kasih banyak Pak. Ini saya atas pertanyaannya, saya coba share screen singkat ya Pak. Ya, dari teknologi Pak, tentunya saat ini ada namanya 3 rotor chiller dari Carrier Pak, yang dimana konvensional screw itu twin screw, gambarnya sebelah kanan ini, dan 3 rotor sebelah kiri. Ini bisa dilihat kapasitas dari 3 rotor itu bisa sampai 600 TR, ini masuk centrifugal range capacity dan better efisiensi, sehingga didapat untuk full load-nya 0,53 dan cons IPLV bisa 0,509 kW. Dan tentunya saya juga sampaikan beberapa Pak sistem juga instalasi di sini di Indonesia khususnya saat ini masih sistemnya standar Pak. Jadi menggunakan satu chiller konvensional 1000 TR dan difokuskan di 712 30 35. Nah, kita kalau di luar negeri sudah familiar Pak dengan series counterflow. Di sini kita bisa lihat 500 TR kali 2, ada lead chiller dan leg chiller. Beda temperaturnya, di sini dari dia 12 entering dari building, itu tidak langsung 7, tapi 9,5 dengan flow rate yang sama, 167,9 liter per second, baru dia ke building 7 derajat. Sebaliknya untuk kondenser, dari 30, 32,5 ke 35, nah ini didapat Pak. Kalau kita seleksi 1000 TR1 chiller dengan full load yang lebih better, 0,545, dan IPLV-nya 0,594, nah Untuk chiller, kita seleksi saja chillernya tidak bagus, Pak. Misalnya 0,57. Tapi dia nanti IPLV sudah untuk lead-nya 0,51. Di leg chiller itu jadi lebih ringan, 0,547 dan IPLV-nya 0,494. Nah, ini salah satu lagi nih Pak Rana, mungkin bisa disoundingkan untuk sistem instalasi menggunakan series counterflow-nya.
Ya, ini series ya. Cuman yang IPLV lebih rendah, ini IPLV loh, bukan NPLV. No wonder it is much more lower kalau IPLV. Oke. One thing, pertanyaan saya juga, komen saya, ini kita tadi Anda mention mengenai chiller plan efficiency. Chiller plan efficiency bukan hanya chiller tapi terdiri dari pompa. Satu hal untuk menurunkan chiller plan KW adalah menurunkan pump kilowatt dengan cara chill water flow-nya diturunkan serendah mungkin. Nah, dengan itu berarti delta T-nya dibesarin. Itu salah satu approach sebetulnya. Delta T chiller dibesarin, chill water flow-nya lebih rendah, ya. Dan kalau dia lebih rendah, pasti pump kilowatt-nya turun. Karena apa? Karena kilowatt itu berbanding pangkat 3 daripada flow. Itu salah satu approach yang menurut saya kalau chiller plan. Oke, saya kira kita selesaikan. Ya, terima kasih banyak Pak Dany. It is very interesting to have your presentation, and it is very, very useful for us to know about the chiller technology in the term for the energy efficiency. So, we have listening to the all 4 speakers and going all through the Q&A session. Now is the chance for the Q&A from participant. Then I have already, saya sudah punya beberapa, I have already some of the question from the participants sent by the Q&A panels. Okay, the first question is addressed for you, Maxine. Okay. Hello, Maxine. Are you still with us? Hello.
I am.
Yeah. Okay. This is the question from the participant. It's come from Mr. Nur Abdillah Siddiq asking about like this. Based on your explanation, there are roads to net zero strategies such as PV generation, lighting by LED. The question is, why is the smart window not included in the strategy? Please answer the question, Maxine. Yes.
Yeah, thank you. And it's an important clarification. And I'm sorry if it wasn't clear in my presentation, but smart windows and high-performing windows are definitely included within what we call high-performing building envelope. So that's much about the insulative, the building fabric, the brick, the walls and the roof, but also the glazing, because as correctly mentioned in the question, huge heat loss or heat gain through windows. So high performance glazing, depending on which climate, different technologies will be most relevant and effective, but definitely included. And thank you for that reminder. That will make sure to make very clear. Thank you.
Okay, of course, this is an interesting question, but all we know is that the air conditioning contribute on the consumption from building energy consumption about 50 until 60%. And from the cooling load, the building envelope contribute about 70 until 75%. It's very, very important to manage with the efficient building envelope. Okay, so that's the only question from your side. Now is the question from the floor for Pak Ignesjz. Okay, Pak Ignesjz, are you still with us? Halo Pak Ignesjz.
Ya.
Okay, ini pertanyaan dari Pak Faton Saulina. From your experience, what do you think the top 3 challenges? I don't know what is the 3 challenges, but maybe you, from your slide, great Pak Ignesjz. Jadi kira-kira mungkin pertanyaannya begini, apa kira-kira tantangan yang terbesar dari building sector atau properties untuk mencapai net zero energy building? Kira-kira begitu Pak Ignesjz. Tolong dijawab singkat, karena waktu kita ini, kita sudah lewat jam 6, saya hanya dikasih sampai 6.15 Pak. Ya Pak Ignesjz, silakan Pak. Halo Pak Ignesjz.
Oke.
Ada suaranya Pak, masih di mute kali.
Sekarang udah?
Nah udah, baru aja masuk.
Oke, saya coba di bahasa Indonesia ya supaya lebih cepat gitu ya. Jadi pertama adalah kesadaran gitu ya, kesadaran dari para pelaku untuk juga selain melakukan usahanya dari segi profit juga memperhatikan lingkungan, karena kalau lingkungannya rusak kita juga nggak bisa berbisnis gitu. Itu belum banyak disadari gitu ya, sehingga saya masih terlalu banyak juga teman-teman saya di properti yang masih belum memiliki perhatian terhadap ini ya. Jadi mungkin cari profit aja gitu ya. Jadi ini tuh harus dibalanskan gitu pertama ya. Jadi kedua ini aturan-aturan gitu. Aturan-aturan ini memang harus juga mendukung dan jelas gitu ya. Jelas dan dapat dilaksanakan secara baik gitu. Dan ketiga saya kira ketersediaan daripada pendukung-pendukungnya seperti material-material yang bisa mendukung dengan harga yang murah, seperti misalnya fotovoltaik tadi kalau disubsidi pemerintah deh untuk sekian tahun gitu ya. Itu kan bisa murah dan orang bisa beli, kita bisa pasang di roof masing-masing dan sebagainya gitu ya. Jadi saya kira tiganya itu Pak, kesadaran, kemudian aturan dan juga kesediaan daripada material yang mendukung untuk bisa energy saving dan carbon saving tadi Pak.
Oke. So terima kasih banyak atas jawabannya Pak. Barangkali sekarang barangkali ada pertanyaan dari floor untuk Pak Dany Watanabe. Pak Dany, you are still with us?
Ya, Pak Rana.
Ya, oke. Ini ada pertanyaan dari Pak Nur Abdillah Sidik juga, ya, mengatakan bahwa R1233ZD itu katanya still contain fluorine and fluorine, which is for me is still a question. So maybe you can explain the HFO with this R, your refrigerant 1233 is HFO, right? It is what molecule? Sorry, please answer that. Is it right that it's still contain the fluorine?
Yes, ya untuk HFO atau dikenal dari hydrofluoroolefin,
yes,
sendiri adalah chemical name dari trifluoropropane. Nah, untuk bicara HFO saat ini adalah future refrigerant Pak. Jadi itu terbaru dari HFC. Nah, untuk kita bicara chiller yang menggunakan elektrik. Sehingga kenapa dibilang future? Karena satu yang tadi saya sampaikan, untuk tingkat safety-nya itu sudah A1 dan global warming potensialnya kurang dari 1 ODP-nya itu 0, Pak. Itu tambahan dari saya, Pak.
Oke, jadi kita bisa simpulkan bahwa R1233 ini adalah satu refrigerant yang JWP-nya rendah banget, satu. Yang kedua, ODP-nya 0, berarti memenuhi. Tapi pertanyaan saya tadi, apakah benar bahwa R1233 itu masih mengandung klorin dan fluorin? Karena kalau ada klorin, bagaimanapun dia pasti punya ODP, Pak.
Ya, sementara ya Pak, kalau kita coba cek ya dari refrigerant manufacturing ya, kalau untuk carrier kan tidak memberikan refrigerant, memproduksi refrigerant ya.
Ya.
Hasil tesnya non klorin Pak, sehingga ODP-nya memang benar-benar 0 Pak Rana.
Yes. Then it is very clear bahwa HFO1233 is not containing chlorine at all.
Yeah.
That's why the ODP is 0, right?
Yeah, ODP 0 Pak.
Yes. Okay. So thank you very much. Hold on a second. Okay, there is a last question for Maxine. Okay, Maxine, about your program on what you call for the government strategy and drafting regulation. Okay, so what is the role? The question is, what is the role of community, especially all the professional and industry association? Hello, Maxine, are you still with us?
Yeah.
Okay, so what is the role of community, especially from the professional industry association, on developing the regulation, on strengthening adoption of the, okay. Please.
Yeah, thank you. So, I mean, as I mentioned in my presentation, we see that there's a huge value in including stakeholders along the journey of developing regulation, developing a strategy that includes not only the building code, but other policies. because this helps industry prepare. It also helps to get the balance right between prescriptive and performance-based requirements. If industry and the stakeholders that are actually going to be delivering on the actions are included all along. So that's one of the key reasons. And then another one is, and I think the reason behind that is because if the industry and the market have very clear signals from regulation, the market will adapt itself. So it's important to give them the tools to be able to do that and the information for them to be able to do that. And then the other point quickly is around the fact that they will probably have the data that would be required to gather the evidence base around all of the multiple benefits that can be achieved with low carbon and energy efficient buildings. So engaging with them will help identify where the different data points sit to be able to get the evidence to bring everybody on board.
Okay, thank you very much, Maxine. And now we have listening to the 4 speakers and going all through Q&A session. So, but of course, there is just some of the remaining question is not raised yet up. So the remaining question will be answered by email arranged by the committee. So before we end our session, okay, please allow me to conclude and summarize all the presentation and all discussion from our breakout session. Okay, this is the summary. 1, the building sectors need to have energy saving program as well as low carbon embodied program towards net zero energy and net zero carbon. So this is the point. Number 2, we have to strengthen the adoption of mandatory building energy code with an objective to ensure the energy efficiency in building sectors by implementing the net zero energy building concept and high building energy efficiency. Number 3, the developers has to start to go for building energy efficiency through widely implementation of the green building and also by applying the renewable energy as a photovoltaic, which in this case need a support from government and the incentive policy form. Let me talk to the government about that. Number 4, there is a recommendation that Indonesia shall revise its maps upward by 20% to harmonize with the major Asian economy by 2023, 2 years from now. And by 2025, Indonesia and all Asian member states align with the U4E, United for Efficiency, model regulation wherein economies of scales are already driving down cost of the inverter air conditioning. So this is about the inverter air conditioning option. Number 5, chiller technology in the future using the low GWP refrigerant and zero ozone depleting potential and available technology with much better COP, higher efficiency, and also towards the chiller plant system efficiency, and not only concerns to the chiller's efficiency. So beside the chiller efficiency, we have also to consider about chiller plant efficiency. And the last point is all of the above point, the above 5 points will ensure that the greenhouse gases will be reduced as targeted to save our planet and the global warming issue for sustainability and for our next generation. So distinguished ladies and gentlemen, before we close, let me give appreciation and please give a big applause to all of the 4 speakers for their amazing presentation and a great contribution. Big applause for the speakers. Okay, thank you. And to the committee, Ibu Anggi, Pak Salim, is there any photo session for this? No, right? Okay. So now time is already 6:15, and it is. So we have to thank you very much for the committee that gave us another 15 minutes, and now it's the time already limited. So this is the end of our session. Again, thank you very much to all speakers, Ms. Maxine, Pak Ignesjz, Virginie, and Pak Dany, and to all participants who joined this virtual session, and to all who makes this event run successfully. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Now we close the session. Thank you.